In the circuit, the galvanometer G shows zero deflection. This is basically the galvanometer. This is R. If the batteries A and B have negligible internal resistance, what will be the value of R, right? These two have negligible resistance, and these are the two batteries basically, right? And they have negligible resistance. Now, these are the two resistances in the circuit, and galvanometer shows zero deflection. That means I through this must be zero, right? Now, when can I be zero, right? If the potential difference across this arm is what, 2 volts because of the battery, and potential difference across this is also 2 volts, then in that case what will happen? There will be no potential difference, and hence no current will flow in this loop basically, right? So that means in this loop I should be such that I into R should be equal to 2 volts. Are you getting it? So that means if let us suppose this is loop 1 and this is loop 2, in loop 1, if we use the Ohm's law, 12 will be equal to I into 500 plus R, right? So from here IR equal to 2, this was the first equation basically. This will give me R will be equal to 2 by I, right? That means 12 will be equal to, or rather we can directly use IR equal to 2. 12 will be equal to 500 I plus IR. IR is what? 2. That means I will be equal to 10 by 500, right? This will be equal to 1 upon 50, right? So I is 1 upon 50. That means, and IR was 2. That means R will be equal to 100 ohms, right? So this is the answer. So this was a relatively easy question. It's just that you have to, just see the concept that if 2 volts is the potential difference across the battery, then the potential difference across this should be, 2 volts itself, right? So no current will be flowing in the circuit because there is no potential difference. Both are at the same potential already, right?